In the previous sessions, we have been looking at conjugation, right? So let's look at the relation of conjugacy. Given a group G under an operation star, for A comma B in G, we define a relation A relates to B. So A relates to B if and only if there exists an element in G such that B is equal to inverse of X times A times X. So here B is conjugate of A in G. That's how we read this. Conjugacy is an equivalence relationship. So when we say equivalence relationship, what do we mean? We say that it is reflexive, it is symmetric, and it is transitive. So let's look at it one by one. So for all A, B, and C in G, A is a conjugate of A for all A in G. So let's see how we can show that. There exists the identity element in G such that A is equal to E inverse times A times E. Now, E inverse is what? E itself. E times A is A. A times E is A. So A is conjugate of A. So that means every element of G is a conjugate of itself. Symmetric. B is a conjugate of A if and only if A is a conjugate of B. So let's again prove that. So let's start with B is a conjugate of A. Then we can write this in this form. So B is equal to X inverse times A times X for some X in G. Now let's left multiply by X on both sides and right multiply by X inverse on both the sides. What do we get? We get X times B times X inverse is equal to X times X inverse times A times X inverse. So here X times B times X inverse is equal to, now X times X inverse is E times A, and again here X times X inverse is E. So which means A is equal to X times B times X inverse, which implies A is a conjugate of B. So we started off by saying B is a conjugate of A, and we ended up with A is a conjugate of B. So that means it is symmetric. Now let's come to transitivity. B is a conjugate of A, C is a conjugate of B, implies C is a conjugate of A. So the first relation can be written as B is equal to X times A times X inverse, and the second relation can be written as C is equal to Y times B times Y inverse. So here X and Y are in G. So now C is equal to Y times B times Y inverse. In this we substitute B with this. We get C is equal to Y times X times A times X inverse times Y inverse. So we have now, by regrouping them, remember we are talking of groups, so which means associativity applies. So we can write it as Y times X times A times X inverse times Y inverse, and this can be written as C is equal to Y times X times A times Y times X inverse, which implies, what does this imply? It implies C is a conjugate of A. So that means it is transitive. Okay, so now we have shown that conjugacy is an equivalence relationship. Let's look at an example. Let G equal to S3 equal to E permutation 1 2, permutation 1 3, 2 3, 1 2 3, and 1 3 2. Now let's take A is equal to permutation 1 2. So let's do the conjugation with permutation 1 2. So 1 2 times 1 2 times 1 2 inverse. Here 1 2 times 1 2 inverse is E. So we are left with permutation 1 2. Now here, if we evaluate this by taking the second element of G, so 13 times 12 times 13 inverse, we get 23. Now let's take the next element in G, 23. So 23 times 12 times 23 inverse. If we evaluate this, we get permutation 1 3. Now let's take the next element 1 2 3. So 1 2 3 times 12 times 1 2 3 inverse gives us 23. And taking the next element, we get 132 times 1 2 times 132 inverse. Evaluating it, we get permutation 1 3. So 1 2 is the conjugate to 1 2, 1 3, and 2 3. Because of symmetricity, we can say 1 2, 1 3, and 2 3 is the conjugate to 1 2. That means all the three two-cycle permutations form a conjugacy class. So this conjugacy class is written like this. Conjugacy class of permutation 1 2 in S3 is equal to 1 2, 1 3, and 2 3. So it is a set of elements in G. So the conjugacy class of A in G is equal to X, where A and X are in G, and X is the conjugate of A. This is the equivalence class of A in G under conjugacy, called conjugacy class. Conjugacy class of A in G is a set of all elements of the type X inverse times A times X for all X in G. So that was relation of conjugacy. It is an equivalence relationship, and we have seen it using an example of S3. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.